So the speed of the light is fundamental in Einstein's theory of special relativity.
The speed of light is the ultimate speed limit. Nothing can go faster than the speed of light.
3 times 10 to the 8 meters per second.
And light always travels with that speed.
Which is very, very fast.
Being actually able to measure that, even in a lab demonstration, high school lab demonstration, is kind of exciting.
It allows students with a simple setup, with a laser pointer, and a little bit of equipment to measure a constant that drives the way the universe works. So what we do is we take a light pulse and we send it on 2 paths. We send it on a short path and a long path. And by measuring the difference in time it takes for it to go a short distance to the long distance, if we know the distances, then from that we can extract the speed of the light along the speed difference for those 2 different paths.
Really, in the span of 40 minutes from setup to interpreting the results, we had calculated the speed of light to less than 3% error.
I have a pen and paper, I write things down, and things are beautiful. While in an experiment, things are fuzzy sometimes. But that's where the fun is.
I like having the kids play with it, and it's not a frustrating thing as far as, because it's tangible, they can see the laser and they can see the results. One of the really wonderful things about these labs are that they're completely inquiry-based. Students are given the opportunity to kind of express their creativity and go through and attempt the labs and learn a lot of the physics their own way. It's a really powerful skill for understanding something.
I work on the CMS Collaboration, the Compact Muon Solenoid. It is a 3,000-person collaboration based in Geneva, Switzerland, on the Large Hadron Collider.
So we are probing basically the smallest constituents of matter, trying to understand really what our universe is made out of.
The CMS experiment is gigantic. It's called Compact Muon Solenoid, but it's actually not very compact. It's the size of a 6-story building. It weighs 12,500 tons, which is as much as 30 747 aircraft.
It's a very big project, so you cannot do it alone. People share ideas. It's always too good to have those ideas collide. Right? We not only collide particles, we also collide ideas.
The more diverse opinions you get, the better your science is going to be.
The LHC launches particles, protons in particular, and smashes them together once every 25 nanoseconds, which is kind of crazy.
We use the most famous equation known to man, E equals mc squared, and we trade E, the energy, the speed of the little particles going very, very fast, to create new M, new matter, new heavy things that haven't existed anywhere in the universe except in very special places or maybe right after the Big Bang.
And so these particles come from the collision point and create a shower, a spray of particles outwards from that point. And our detector is built in these different layers around this point to look for different signatures that are unique to different particles.
This experiment here uses a sensor to detect the light from the laser beam to measure the speed of the light. Similarly, the CMS detector also has lots of detectors that can measure both energy and time.
The photodiodes that you use to collect the light, we use those in our experiments. We use lasers all the time for calibration, measuring the energy in our detector.
Here at Cornell, we are involved in the upgrade of the CMS detector for the so-called high luminosity LHC. We will be able to probe much more rare processes, and we will also be able to measure the properties of the Higgs boson much more precisely. But of course, the most exciting thing would be if we found something new like supersymmetry or something that would allow us to explain, for example, dark matter.
It's really special being the first person to teach physics to kids, being the first person to do those demonstrations and get kids to kind of think a certain way about the world. It's a really powerful skill for understanding something.